Hey guys, Mr. Burden here. I just wanted to go over this week's warm-up. It's week 5 of our online learning, distance learning unit. And so last week we worked on multiplying polynomials and more importantly, multiplying binomials, bi meaning two. So two different, either parentheses or two different terms. This week I'm kind of showing you the box method, and I'm going to show you this box method with figures, right? Pictures. If we look at our key here, we can see that this represents 1, this represents x, and this represents x squared, right? So basically we've got a representation for three different terms. Okay, so let's read the instructions. Identify the factors being multiplied based on the models. Complete the model to represent and determine the product of the two factors. Okay, so what are our factors here? And let's go ahead and redefine factors for just a second. Factors are the numbers that you multiply to get an answer in a multiplication problem. Sorry, giving away the next answer. And then the product is the answer to the multiplication problem, right? Factors are the numbers in the problem. Product is the answer to the problem. Now, when we're looking at polynomials, we know that we have terms. We're not necessarily multiplying just numbers like 2 times 3. And so we're dealing with terms, and terms can have constants. They can have single variables, and they can have variables with exponents. And we've learned about the exponent rule. We've learned about multiplying binomials. But I want us to look at what it really means and really break it down. And so what does this represent right there? Well, that represents, as we see right here, x. How many x's do we have? Just 1. So we're going to start writing our first factor. And so our first factor is x. And then when we look at all of these, they are represented by that. And so then I have 1, 2, 3, 4, 5. So it's going to be x plus 5. Okay, and so that's one factor, right? Because that's all that equals x plus 5. Now, down here, I have, I got more x's, right? And so I have 1, 2, 3, 3x. And so I'm going to multiply both of those factors together. And so it's going to look like 3x times x plus, come on now, get over here, x plus 5. There you go. All right, and so last week we worked on doing this this way, using the FOIL method, right? But this week we are going to use this box method here, okay? And so we're going to try and get this product. Now, when I am multiplying two x's together, it is x times x, which gives me x squared. Now let's really dive into how we get the quote-unquote square. So if I go and let's say that I wanted to put tile down on the floor of a room. Let's say that the room has one side that is 3 feet long, and actually it's a square room, and the other side would be 3 feet as well. Okay, each tile is 1 square foot, right? Now, how do I get squares? Now, I could draw out each of the tiles, right? And then just count them up, right? And so that would be 9 tiles, okay? But 9 tiles is equal to, how do we get that? 3 times 3. I did 3 times 3, right? Okay, and so 3 by 3 is the same as 3 squared, right? And that's where we get that term, squared, 3 squared. And then we know again that that all equals 9. Okay, so going back, if I have 1x times another x, I'm going to get a square. Okay, now if I have that 1x, and each time I'm just going to square it. Okay, so how many squares do I have? How many x squareds do I have? I've got 1, 2, 3. Good. So part of my product is going to be 3x squared. Now, I'm going to multiply 1 times x. 1 times x is just x. Okay, and I keep doing that. Okay. And if I keep doing that all the way down, I'm going to get... How many x's am I going to get? Well, I'm going to get 15 x's. So it's going to be 3x squared plus 15x. Now, do I have any constants over here? No, because I don't have anything left over in this area where I would multiply maybe like a 1 times another 1, okay, or a constant by a constant. So I don't have that. So my final product is going to be 3x squared plus 15x. Okay, and so going back, if I want to, let's say I want to take this initial set of factors, my initial problem, 3x times x plus 5. And let's set that up. 3x times x plus 5. Okay, great. Now, we've done this kind of already, and this is just going to show exactly what we did with the model. Okay, 3, and we do our coefficients first. Now, if there's no coefficient, we just assume that it means 1. So 3 times 1 is 3. X times x gives me x squared. Now, I'm going back to the 3x. 3x times 5, so 3 times 5 is 15. X, you've only got one of those, and so then that is your final product there. Guys, this is just a breakdown of problem number 1 on our warm-up this week. Hopefully this gives you enough information to move forward and go with the rest of the warm-up. Good luck with everything. Please sign on to my classroom if you need any additional help. The link is sent to you in an email, and it is on your